All right, we're looking here at polynomial functions that are given to have at least one rational zero for sure, and we want to find the remaining zeros. Here we're looking at a degree 3 polynomial, but it could be any degree polynomial. But if you have a degree 3 polynomial, once you find one zero, and then you divide the original polynomial by x minus the zero you found, you will be getting a quotient which is of degree 2, and you can get all the zeros of that quadratic polynomial by using quadratic formula or factoring. So the first step is to find all the rational zeros by using synthetic division to see which one actually works, and then the remaining quotient that is quadratic, either factor or quadratic formula. If it is a higher degree polynomial, then instead of step 3 becoming a quadratic polynomial, you will have a higher degree polynomial and you have to keep looking for more rational roots, and there are other ways of finding the remaining zeros. For now, let's just work with cubic functions. So why don't you pause the video here and see if you can do step 1 by looking at possible rational zeros. Do you remember how to do that? Plus or minus numerator over denominator, where numerators are a factor of constant term and denominator are all factors of the leading coefficient. So go ahead and pause the video and do step 1 on your own, and then you can check it. So let's see if you got the same answers if you've come back from pausing the video. Remember, our numerator is going to be plus or minus the factors of constant term 1 or 7, and denominator are all factors of 3, which would be 1 or 3. So our possible rational zeros are 1 over 1, or 1 over 3, or 7 over 1, or 7 over 3. So plus minus 1, 1/3, 7, 7/3 are all rational zeros. So now we are going to take a look and see how to find the zeros of this polynomial by doing synthetic division. So let's work on that next. So let's take a look and see which of these potential rational zeros actually work. You can see that from Descartes' rule of signs, since there is no sign change, there are no positive real roots to this polynomial. So none of the positive rational zeros are going to work. So we can start with -1, and you can see here we have the -1 is one of the roots that we want to try and see if it works. 3, 10, 10, 7, highest degree to lowest degree. Write down all the coefficients. If there are any missing terms, you would put 0 as placeholders for that term. In this case, we have all of the terms. So now all we have to do is synthetic division. So let's see, you can pause the video here and do synthetic division on your own and come and check your answers, or let's do the first one together in case you don't remember how to do synthetic division. So bring the coefficient 3 down as is. So this 3 here will come and sit here. Then you want to go here and figure out how to multiply -1 and 3. So -1, which is right here, times 3 will give you what? -3. So enter that there. And then up and down you add. So 10 minus 3, which will give you 7. Then -1 times 7. Put the answer here. So that will give you -7. Add 10 and -7, and that will give you 3. -1 times 3, which will give you -3. Good. And then 7 minus 3, which will give you a 4. And so 4 is going to be our remainder, and 3x squared plus 7x plus 3 is our quadratic. Since your remainder is not 0, you know -1 is not going to be one of your roots. All right, so -1 is crossed out. So now we have to move on to -1/3. So do the same thing, but with -1/3. So pause the video here, fill in all the blanks, and then come back and check your answers. So assuming you've come back from pausing the video, you probably got something like that. So 3 came down, -1/3 times 3 is -1. Add those two gives you 9. -1/3 times 9 is -3. Add them together, 7, negative 1/3 times 7 is negative 7/3. 7 plus negative 7/3 is not going to give you 0, so you know that's not going to work. So let's try negative 7/3, because I can already see that if I put negative 7 here and 3 comes down, negative 7 times 3, negative 21, plus 10, negative 11, times negative 7 is 77, so it's just way out of the question. So let's try 7/3. And so negative 7/3 times 3, which will give you negative 7. 10 minus 7 is 3. And 3 times negative 7/3 is another negative 7. Add them gives you 3. And then another negative 7 plus 7 will give you 0. So yay, this is our 0, which means that negative 7/3 is our 0. So we have found 1, 0. And so that means our quotient is 3x squared plus 3x plus 3. We can factor out a 3. So we have x squared plus x plus 1. That's our quotient. And so now for the third step, we're going to have to set this to 0 and solve for x. So that would mean that you really are just looking at x squared plus x plus 1, setting that equal to 0. And our remainder is 0, which is how we know that negative 7/3 is one of our rational roots. All right, let's take a look at step 3 then. Step 3 is now finding the roots for x squared plus x plus 1 equals 0, and that would be a quadratic formula. So please pause the video here, and then we will check and see if you have the same answer as what I got. All right, let's see if you got the same answer as me after you did the quadratic formula. So minus b plus or minus b squared minus 4ac over 2a. And so square root negative 3 will give you square root 3i. So you can see our remaining two roots are imaginary. Whenever you have a root like that, always write it in the standard form for complex numbers. So real part plus imaginary part. So separate it out and reduce if possible. So now we have all our solutions, and so h of x has the zeros, negative 7/3, which we got from doing the synthetic division, and then the negative half plus 1/2 square root 3i, negative 1/2 minus 1/2 square root 3i. Those are all the three zeros of this cubic polynomial.